Chris Esplin here. We're going to cover the Firebase Node client today. Okay, so Firebase provides a bunch of different ways to access it. The primary way is via a web, iOS, or Android client. The point of Firebase being to create server-free applications. I mean, they are the back end as a service, so Firebase is handling as much as possible for you. Now, you will occasionally want to create a server. And so in that case, I like to use Node. You can also use Java. I think there are some other ways to do it as well, but I stick with Node. I'd like to cover creating a Node client and then do some basic Firebase operations in JavaScript. Now, these operations are the same in the Node client and the web client. So once we get the Node client configured, everything else after that is transferable directly to your web client. So yeah, the configuration for the web client is going to be slightly different. But once that initialize app call is made, you're good to go with the web client, Node client, doesn't matter. The API is identical. Okay, so how do we get connected? First, we've got to install the Firebase SDK. So in this case, it's npm install. If you want to init and have a package.json, you can say npm init, and you can bounce through all those. That looks like this. Is this okay? No. Okay, aborted. I already have one. Okay, so you can npm init, and then you can do npm install save Firebase. Okay, that's it. Got it. Done. Okay, so now you can go into your index.js or whatever file you're using and require Firebase in. So let's get this nice and big. There we go. Okay, I'm going to hide the files. We now know what we got. Okay, so you require in Firebase, and then you call firebase.initialize app. You need two things. You need a database URL, and you need a service account. The service account.json file is created over here on your console.cloud.google.com API Manager Credentials tab. Okay, make sure you have the right project. I've got a ton of projects. Lots of people have a ton of projects. Don't make this mistake. I've made it before, and create a service account for the wrong project and try to use it for your Firebase project. That's ridiculous. So in this case, I've got a Firebase project over here called Quiver2. You can see right here, it's called Quiver2. That needs to match up. That needs to match up to that. Okay, so go to your console.cloud.google.com and make sure that Quiver2, in this case Quiver2, whatever your unique name is, matches to your Firebase. Then create credentials, create a service account key. You can, if you already created one, you can recreate one. You can create a new service account. That's typically what you want to do. You say, hey, some arbitrary name. All right, download as JSON, create. It'll download the file to your computer. I'm not going to do it right now. It's a pain in the neck to have a whole bunch of these things created. I just have to delete it anyway. But I've got access to one. You can see it over here. I've already saved it, Quiver2 service account.json. All right, it's a big file full of service account keys. And once you get that, you have administrative access to your whole Firebase. Now, you could get rid of this line, and then you'd only have public read-write access. That's very rarely the case, that you want just public read-write access. Usually you create a server so you can do administrative tasks. So in this case, you've got service account and then your database URL. Now your database URL, pretty straightforward. It's going to be that. Okay? So you go to your database and look at your URL for the database. There you go. It's right there. Okay, that's your database URL. Next, now we've got initialized Firebase. We can start playing around with it. We're going to do, we need a ref. We need the initial root ref. So we're going to say var.ref equals firebase.database to get the database SDK. There are other SDKs. There's an auth SDK, a storage SDK. Although there's no storage SDK in the Node client. That's only in the web client right now. Anyway, ref. Now I can pass a string in here to create some nesting and to reference a deeper part of our structure here. So I'm actually going to do that. I want to work here in the node client node. Okay. So because the whole app is going to rest underneath this node client node that I just created, I'm going to put that in right here. And now we're going to say, okay, let's collapse this. All right, let's create a new ref. Let's call it messages ref. So var messages ref equals ref.child messages. All right. So let's push some data to the messages ref. Messages ref.push name Chris admin true. Goodness gracious. That is annoying. And so we've got a string, we've got a boolean, and we've got a count 1. All right. And since it's a message, we should have text. Text. Hey guys. All right. So now I'm going to run Nodemon index.js. So my index file, I'm going to run it. Here we'd use Nodemon. Nodemon, you can npm install g Nodemon to use Nodemon across your whole machine. Global installs the preferred way to use Nodemon, and it just runs your file after every change. So it'll run it initially. Oh, there we go. Message ref is not defined. All right, messages ref, because we're going plural. Save that. Okay, it reruns. There we go. We got some messages. So it pushed it. Admin true. That'll be a boolean. That'll be a number. That'll be a string. That'll be another string. Excellent. Okay. So we used the first way to set data, which is .push. Now, .push creates what's called a push key. The push key is this guy right here. Push keys are critical to Firebase. Push keys are kind of like timestamps, but with a bunch of randomness thrown in so that they don't collide. So imagine a large application where, say, 100 people are simultaneously pushing to the same data point. So 100 people are trying to push messages on. Now, if you used a zero index array like you use in JavaScript and JSON, like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and those 100 people tried to push to node 11, you'd have a collision. We can't have collisions. So Firebase cannot support zero indexed arrays as actual arrays. Now, yeah, you can fake it and put zero indexed arrays in yourself, but just don't ever do that. That is an anti-pattern, not how Firebase is supposed to be used. Firebase is built off of lists. You want to create lists of objects, collections. And to create these collections, you need to use push keys. And there are multiple ways to use push keys. Okay. But you need to use the Firebase SDK to create the push key. And here's another way to do it. I can say messages ref.push and pass some data in and it'll just go. Every time I rerun this, it'll push another one. Okay? It'll just keep going. Well, how about this? I can also say var message ref equals messages ref.push. Not pass in any data, and all it'll do is create a new reference. This reference is going to have its own unique key that will be generated in the millisecond that I run it and will be sortable by millisecond. Okay, so every millisecond, you'll create a different push key. And let's say, okay, so they're sortable by millisecond. That's what I'm trying to say. If 100 people push in the same millisecond, those 100 records are all going to sort in a jumbled manner. But the next millisecond, those push keys will actually sort down alphanumerically. So these push keys are alphanumerically sorted by millisecond. That's great. It lets you do a sorted, time-sorted list just by sorting by those keys alphanumerically. And Firebase will, by default, always sort by key alphanumerically. So you're sorting by time by default. Okay, now that's one you got to use these push keys. You need the time sort to really make Firebase sing. So in the second or the millisecond that I call .push, it's going to create me a push key that will sort to that millisecond. So I can say message ref. Now I can say message ref dot set, and I can pass my data in. So now instead of pushing directly, I get this. Now watch this. I'm going to console.log out message ref.key. All right. Now there's been a change in prior videos and in prior versions of Firebase. It was get key as a function. Well, that's gone now. Now it's key. So I run it. You see it created the key. That key matches that key, and then I set the data to that key. All right. So I could create a lot of these. I could go in a loop and say for var I equals 10, I minus less than 10. What am I doing? Equals 0. I plus plus. So I can do a loop and say console.log messages messages ref.push dot key. I should probably use proper for loop syntax. I do not write very many for loops. So it'll go through and it'll make a whole bunch of these keys, and you'll see they all just sort. They're all within this. A lot of them are within the same millisecond, but they're still going to be unique. And then the final one, well, this one right here is the one I'm actually saving to. So these guys are just basically I'm just generating push keys. Okay, so that's the first key concept of Firebase. These push keys. Maybe it's not the first key concept. An important key concept. I think the first key concept is Firebase gives you a arbitrary data structure. So it's completely arbitrary, and it backfills. So if I say now instead of saving to messages, I want to save to some arbitrary structure. Well, check this out. Now I've got some arbitrary structure. And when I delete it, watch it delete all the parents. So I can save whatever data I want, and it'll create whatever data structure is necessary to get there. And if I delete the data, it'll delete whatever's not supported any longer, whatever parents don't have children. I mean, with JSON, you can't have a childless parent node. That's not how it works in JSON. That's not how it works in Firebase. Okay. All right. So we've covered a couple things. We've covered .push, which gives us these unique keys, and these unique sort of spots to hold your records. So when you're creating list collections, you need to use .push to push to the node. In this case, messages. Okay. And then we covered .set, which takes any ref and lets you set whatever you want underneath it. So instead of message ref, I can say messages ref, and I can say .set null. I can set the thing to null. Save and is it going to go away? Oh, looks like we had some sort of bug. Didn't like that. All right, never mind. Because you can't set it to null. I think I can do update. There's another way to set called update. So I update. In this case, I'd say ref.update. And I'd say messages null. There. All right, so that wiped that out. Now this is really fun. I can say messages slash some child equals 1. And I can say messages slash another child is 2. So with update, I can pass in these these paths, and it will do what's called a multipath update, an atomic multipath update. This lets you manipulate your data across your whole Firebase in an atomic manner. A lot of times you want to save a record in two places, say a log for the admin and a log for the user. You could say, okay, I've got messages ref right there. Now I can say var message key equals message ref.key, right? And now I'll say var payload equals just this empty object. All right. Now let's do payload user messages plus message key equals, now I need to have a message. Var message text, hey guys. Okay. So I'm constructing an object. We're going to be this payload object, and it's going to have the message in two spots. User messages and logs. We're going to use the exact same message key. We got the message key off of this message ref right here. So we created the message ref. That gave us a key. We pulled the key off. All we really created the ref for was to get the key. Once you got the key, got that there. I've got an object called payload that has those keys. I save it. All right, so now logs has structure text. Blah, 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 blah. Let's get rid of all this baloney. Okay, so now I have messages text, hey guys. Oh, that didn't work out quite right. Let's see, what did we get wrong here? Let's get rid of the all the unfortunate cruft we got going on. Run it again and test and figure out exactly what's happening. Okay, user messages, we got all right, so the problem is we're calling ref.update with user messages and logs. Okay, so the ref is built off of node client right there. So user messages and logs, that's right. Now message key in this case. Oh, right, okay, so I've got messages ref.key, which is going to be messages. I want message ref.key. So run that. There we go. Okay, let's delete it all. Look at it clean. Restart that guy. There we go. Okay, so now logs has this nice little key. All right, and you got it down here too. So this lets me get a key and save the record, the payload, in two different places. Ref.update payload. Okay, so update lets you do multipath atomic updates. Set wipes the thing out, so it just wipes it out. You can't do set with some sort of weird payload like, well, I guess, let's see what happens when you do this. Let's see what happens if I do pass that whole payload into set. Yeah, it really doesn't like that. So I would say ref set baloney true. So watch it just wipe it all out. So set is destructive. Update, it can be destructive in that if you change a parent, if you change a node and it has child nodes, all those child nodes are going to be wiped out too. But it's a little more surgical, and that update lets you go in and change just little bits and pieces of your data set. Okay, so what we got here. All right, now we got some data. Let's run this a bunch of times and create a bunch of data. Okay, so we're gonna have a whole bunch of these guys. We're just gonna keep running it. Blah, 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 run it again, 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 run it again. All right, so we got, one more time. Let's get 5. Okay, so we got 5 messages now. Okay, under quiver2.firebase.com/node client /logs and /user messages, we have 5. And these guys all have shared keys. That's really convenient. Okay, so now let's not make any more of these. They can keep making them. But what we really want to do now is we want to query the data down. So we've covered how to save data up using .push to create a new push key and to potentially save a new record under that push key. And we've called .set and .update to, with .set, make sort of a clean set on that node, and .update to update bits and pieces of the data structure. Now we're going to start querying the data down. So ref.once value. This returns a promise. So you can only use the ref.once with value. It's the only event that's supported right now with .once. Because all the other events, you typically are going to happen a bunch. And we'll cover that in a minute, but this is a special one. .value can be a once, and it returns what's called a snapshot. I call it a snap. You could call it a snapshot. I think the docs call it a snapshot. I call it a snap just because I type it a lot. Okay, snap's got a couple things. So you got snap.key. You've got snap.ref. We're going to call toString on it because I don't want to just read the whole thing. That's really ugly object. And then we've got read that again. Console snap.val. Val is a function. Okay, I'm going to pass in some of these guys, some line breaks to make it clear what's what in the logs. Okay, so save this. So it'll make some new ones like we had it before, and then it'll start reading it out. Okay. So the key is node client. The key for ref right here is node client. That refers to the node client. It's the basis of it. So the key is node client. The ref. So snap.ref will give you the same ref that we just listened to. So it'll give you the actual ref for that snapshot. And if you call toString on a ref, it will spit out the actual path to the ref. So it's really convenient. I use it quite a bit actually. So HTTPS quiver2 firebase.com/node client. So we know we've got the right ref and we know we've got the right key. And then .val chucks out the object underlying that key. So now let's do .child. Oh, we got a couple things here. I can do .child logs. I can do .parent to walk back up, and .child user messages. I can walk up and down using .child, which you have to specify with a string. You've got to have a child that you're going to, or .parent, which you don't pass anything into. It just goes up. You can also say ref.root. So what happens when I run this? There we go. So ref.root, it's an attribute. It's not a function. It's not root like this. I think it used to be root like that. It's not anymore. It's just ref.root. It lets you go straight to the root. And in this case, the root of my entire Firebase right there. So then I can do fun stuff. I can say, oh, hey, I've got root.child authentication, and I can walk through my node that way. But let's not do that. Let's just do ref, which is the node client ref.child logs once value. Okay. And every time we run it, it creates another one. That's just a fun little surprise every time. All right, so now you see the node is logs, the path is /node client /logs, and we get just the logs. Okay, great. All right. Now what else can we do here? So we've called dot once on the value. We can also do on value and pass in a callback. Now this is going to be different. So instead, once will just go the one time, and it automatically calls off on itself. But on value will fire every single time that I change anything. So it lets me keep memory, like keep the a bit of memory in sync. So for instance, I can say var logs right there, and I can say logs equals snap.val console out console log.logs. Okay. Now every time I change anything, there it went. All right. So let's go in here and say, oh, hey text, hey one guy. Oh look, so it updated right there. So every time anything changes in the data structure at all, the value event gets fired. Now if I call it just once on it, that just goes with the first one that turns itself off. It just listens for the very first load and then turns itself off. If I just pass listen with the dot on value just to the value event, it fires initially for the initial load, then it fires for every single change. That lets me keep a chunk of memory in sync. It's very useful. All right. Now there's a problem with this. There's a problem with the value event. And I like the value event. I use it for small data sets, but you don't want to use the value set for large data sets. Imagine you had 1 million messages. 1 million messages in your log. That's ridiculous. You wouldn't want to call dot on value for that whole data structure. So what you do is you use another event called child added. Now child added will run once for every child. So we're just going to log out snap.val. Again, it returns a snapshot, but it's going to call once for every child. So it called itself once for every child. Now if I add a log, it'll call again. Hey, true. There we go. Now there was no nesting, so it just passed in the value true. If I get rid of it, delete. Okay, doesn't fire for that. But I can say some value out of space true. Okay, some value true. Value true. There we go. Okay. So child added is extremely useful because it lets you listen to your data structure, but listen to the additions to it. Now, the one issue with it is that it fires a single time right at the beginning. That's a little messy. I can also now there's a trick, and this is a little we'll cover these queries more later, but you can use a query called order by key, which just specifies what it's already doing by default, but it's ordering by the key, in this case the push keys, dot limit to last one child added. Okay, ready for this? Okay, it'll only fire for the very last one. Value true. Text. Hey guys, oh. I was gonna say, I'm console logging something else out here. Oh yeah. Because I added one right here, because I added in the in this update statement, it fired for that update. So if I get rid of the update, it'll just value true, the last one. Now if I put that update back in, so it's adding another one. Oh, there we go. So it'll keep going. All right, so limit to last one, order by key and limit to last one lets you listen to just that last child added. That's a useful little trick if you just want to listen to new records. Because that'll listen to that it'll read out the first record. You can skip that first record and then just listen to the added after that. Okay. And we'll get more into the fun query stuff you can do later. Okay, obviously there's also, there are a few others. There's child moved, which I don't use. That's got to do with priorities, and priorities are going out in Firebase. So just ignore child moved. There's also child removed. That's useful. So you see nothing gets logged. One got added, nothing got logged. But I can go over here and say, you know what, let's get rid of this guy. Delete. Whoop. There we go. So the removed fired for that. That just watches for things that go away. It's really nice if you're doing a child, if you've got a huge list and you don't want to use value, the on value, to keep it synced up with your local memory. You can use child added and child removed to change it appropriately. To take it out of memory or add it to memory. There's also child changed. So the value event listens for changes, but added doesn't listen for changes, and child removed and child added, they don't listen for changes. So you gotta listen to hey one guy, back to hey guy again. 1, 2, 3, 4, 5, 6, 7, 5, 6. Okay, there we go. So now you see that guy read out. Let's make this even a little bit bigger. All right. Okay. So if you really want to keep things in sync, but you don't want to listen to the value event, you have to do something like this. Var logs ref equals ref.child logs. Logs ref.on child added. And if I really want to just keep it in sync, I'd do something like dot order by key dot limit to last one, just to get that last one. Console log added snap.file. So if you really want to keep it all in sync, you can do something like this. You want to have an added event, a removed, listen for removals. And you're going to want to listen to changes as well. Got that right here. On child changed. Okay, so that lets you listen to just the new objects, besides the first one, which you may want to skip. But lets you listen to additions and changes. And hey guys, 1, 2, 3, 4, 5, 6. There we go. I want to delete this guy. Delete. So this lets me keep things in sync locally in a very, very sort of specific kind of surgical way without doing a big on value event. Now, if I'm doing a small data structure, yeah, I'm going to use on value. It's much simpler. But half the time you're doing long lists of data. So you want to use these child added, child removed, and child changed events. All right. So I think I've covered everything I'm interested in covering. Let me know in the comments if you have any questions, and have fun with Firebase.